and welcome back to our next video lecture. So as I told you earlier in the previous video lecture that in the next one we are going to learn about some of the interesting patterns. So this is the part 1. For that, let's begin. Now see, we are going to add triangular numbers. See, if we have this 1, this is 3, this is 6, this is 10 and so on. If we combine two consecutive triangular numbers, what are we going to get? We get a square number. So if we combine two consecutive triangular numbers, either these two, the two consecutive triangular numbers, we are going to get a square number. You can see it from here. Like if we add this with this, these 3 with 1, we get 4. And 4 is actually a square number because it is the square of 2. Now similarly, if we add this 3 in this 6, what do we get? 3 plus 6, that is 9. 9 is again perfect square. We can see a square number because 3 square is 9. Furthermore, you can see that in 6, if we add 6 to this 10, what do we get? If we add 6 to the 10, we are going to get 6 plus 10, that is 16. So 6 to 10 gives us 16. 16 is again a perfect square, again a square number because 4 square is 16. This is how you can say that adding two consecutive triangular number gives us a square number. Now numbers between square numbers. So we have learnt about square numbers. Now there is a formula for finding the numbers that are between two square numbers. What is that formula? There will be 2n non-perfect square numbers. There will be 2n non-perfect square numbers between the squares of the numbers n and n plus 1. So if we have two numbers n and n plus 1, then the number of non-square perfect squares that are going to lie between these two numbers will be given by the formula 2n. So 2n will give us the number of non-perfect square numbers or natural numbers that will lie between two numbers n and n plus 1. Between the squares of these two numbers n and n plus 1. Where n is any natural number. So we are going to consider this example. See, we have to find the number of non-perfect square numbers that lie between the squares of 3 and 4. That is between 3 square and 4 square. So we know that, so first of all, let's just use this formula and then I'll check by calculation. See, 3 square and the other one is 4 square. So this is our n and this is our n plus 1. 3 is our n and 4 is our n plus 1. So the number of non-perfect square numbers or directly natural numbers lying between the squares of these two numbers will be given by the formula 2n. That is 2 into 3, that is 6. So there will be total 6 natural numbers, or we can say 6 non-perfect square numbers that are going to lie between the squares of these two numbers. You can now check this also. We know that 3 square is 9 and 4 square is 16. So how many numbers lie between these two? There are, see, 10, 11, 12, 13, 14 and 15. Total 6. You have checked it out. There are total 6 numbers that lie between the squares of 3 and 4. Just use this formula, 2n. Now, how many natural numbers lie between 9 square and 10 square or between 11 square and 12 square? Again, use the formula. I'll do this first part for you and you have to do the second part yourself. So here we have n as 9 and our n plus 1 is 10. We need to find the natural numbers lying between them. This will be given by the formula 2n, where n is 9. So 2 into 9, that is 18. So there will be total 18 natural numbers that lie between the squares of these 9 and 10. Similarly, you will have to do 2n for this case, where n will be our 11 in this time. What do we have next? Now we have question number 2, that is how many non-square numbers lie between the following pairs of numbers. So again, just the same one, you have to use the same formula, that is 2n. Now here, I'll do the first part for you, do the remaining other yourself. Just the same way. So here we have n as 100, n plus 1 is 101 we know. So the number of non-square numbers that are going to lie between the squares of these two numbers will be given by 2n. The answer will be 2n, that is 2 into 100, that is 200. So there are total 200 non-square numbers that lie between the square of 100 and the square of 101. Do this, use the same formula, find the answers for these two parts and this one yourself. It's very easy, just have a hint from here. Next we have adding odd numbers. So C1 is an odd number. There's only one, that is 1 square is 1. Now if we add the sum of first two odd numbers, that is 1 plus 3, it gives us 4. 4 is actually the square of 2. Now 1 plus 3 plus 5, again the consecutive, the successive odd numbers, that gives us 1 plus 3 plus 5 actually gives us 9. That is the square of 3. You can again see that 1 plus 3 plus 5 plus 7. Now one more successive odd number gives us 16. That is the square of 4. That is 4 square. Furthermore, 1, 3, 5, we add 1, 3, 5, 7 and 9, we get 25. That is the square of 5. And similarly, 1 plus 3 plus 5 plus 7 plus 9 plus 11 gives us 36. That is sum of the first, these 6 numbers gives us, 6 odd numbers gives us 36. That is actually the square of 6. So it's so interesting, you can see. And from these examples, we can actually derive a statement, a result, that is, what's that result actually? That result is the sum of first n odd natural numbers is n square. What is the result? The result states that the sum of first n odd natural numbers, the successive n odd natural numbers, their sum is given by n square. You can check it from here also. And if a natural number can be expressed as a sum of successive odd natural numbers starting with 1, then that natural number is actually what is a perfect square. So perfect square is a number, is a natural number that can be expressed as the sum of successive odd natural numbers starting from 1. You can consider this number 25. So how can we say that this is a perfect square? We have to find that whether 25 is a perfect square or not. So we have this method. If 25 can be written as the sum of successive odd natural numbers, we can say that 25 is a perfect square. Let's see that 25 minus 1 gives us 24. Further, 24 minus 3, we are just subtracting the, going to subtract the successive odd natural numbers. 25 minus 3 gives us 21. Now 21 minus 5 gives us 16. 16 minus 7 gives us 9. Last 9 minus 9 gives us 0. So yes, 25 is actually given by the sum of 1 plus 3 plus 5 plus 7 plus 9. So 25 is actually the sum of first, how many? First 5 odd consecutive natural numbers. So 25 is a perfect square. That is derived from this result as well as this result. The sum of first n odd natural numbers is n square. Here we had the sum of first 5 odd natural numbers, that will be given by 5 square, that is 25. What is next? Next is we have to try these questions, find whether each of the following numbers is a perfect square or not. What result are we going to use here? Again, we are going to use this previous one, that if all of these numbers, if any of these numbers, I must say, can be written as the sum of successive odd natural numbers that starts with 1, then that number will be a perfect square. Okay, let's do first part. I'll do some of the parts and the other parts you will have to do yourself, just taking a hint from the examples that I do. First one is 121. Let's subtract 1 from here, we get 120. 120 minus 3 gives us 117. 117 minus 5 gives us 112. 112 minus 7 gives us, it gives us 105. 105 minus 9 gives us, 105 minus 9 gives us 96. Now 96 minus 11 gives us 85. 85 minus 13 gives us 72. 72 minus 15 gives us, you can do it in the rough work also or mentally, it's up to you. 57. 57, I'll write it here, 57. Now after this is our step. 57 minus 17, it gives us 40. 40 minus 19 gives us 21, and 21 minus 21 gives us 0. We can say that 121 is actually the sum of first 11, because 121 is the square of 11. 11 square is 121. 121 is actually the square of 11, we know that, and we are going to say that whether it is a perfect square or not by using this result. So I have found out that finally my answer is coming to be 0 when I start from 1 and I end up at 21. So I can write 121 as the sum of 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19 plus 21. The sum of these first 11 consecutive odd natural numbers gives me 121. So 121 is a perfect square. Yes, 121 is a perfect square number. Let's do the second part just like this. I'm going to erase this one. This is the answer for the first part. Let's do the second part now, and the number that is given to us is 55. So let's check that whether 55 is a perfect square or not by using this method. Okay, let's start it. We have this. Now the second part, 55, start subtracting 1. 54. 54 minus 3 gives us 51. 51 minus 5 gives us 46. Now 46 minus 7 gives us 39. 39 minus 9 gives us 30. 30 minus 11 gives us how much? So 19. 19 minus 13 gives us 6. Now 6 minus 15. 6 minus 15 is actually minus 9. We are not getting 0. So the answer is now going to be negative numbers. We are not getting 0. After this 6, we are getting actually minus 9 and not 0 anywhere. So we can say that since 55 cannot be written as the sum of successive odd natural numbers, therefore 55 is not a perfect square. And we directly know this, 55 is not actually a square of any of the natural numbers. So by this method, we have found out that 55 is not a perfect square. Now the other parts are 81, 49 and 69. Check for these numbers by using the same method. Use hints from my examples and solve these. Check out whether these are perfect squares or not. This will help you in practice also, and you will be easily able to solve the exercise questions. This was all about our video lecture second, and in the next video we are going to learn some more interesting patterns, and that is part 2. We'll meet again in the next video. Bye bye.